Hello and welcome back to a course of pure mathematics, the video tutorial based on G.H. Hardy's famous book on the same title. Today we will look at this problem where we are asked to show that there are infinitely many right triangles with rational side length. I ask you to pause the recording to try and solve it on your own. Okay. We know that A, B, and C are sides of right triangles if and only if A squared plus B squared equals C squared. Furthermore, we can multiply A, B, and C by some constant and still obtain a new right triangle. Unfortunately, they are all similar triangles, but nevertheless a useful fact to know. We all know the 3, 4, 5 triangle, and maybe a few more, but not infinitely many. Try and use the following identity if you are stuck. Pause the video again if you want to have a go, having got this hint. Now, the solution. If we set A equals m squared and B equals n squared, we obtain the following. This shows that if m and n are positive rational numbers, with m greater than n, because lengths are never negative, m squared plus n squared, m squared minus n squared, and 2mn are sides of a right triangle. We may even say that lambda times m squared plus n squared, lambda times m squared minus n squared, and 2 lambda mn are sides of a right triangle. Since there are infinitely many rational numbers, there are infinitely many such non-similar right triangles where we choose different m and n in different cases. Hope you enjoyed this video. Please like, comment and subscribe, and see you again on the next one.